In this video, we'll be discussing row echelon form for multivariable linear systems. So, when practicing the method of elimination, we create equivalent systems, and we do this by either swapping equations, multiplying an equation by a constant, or adding a multiple of one equation to another. This is actually really what we've been doing throughout. Most notably, the last option we've been using for elimination, and it's actually adaptable to more than two equations. Namely, if we had three equations, we could do by swapping, well, we didn't swap any equations here, but what we did do is if we were to add x to this, then we would eliminate and end up with add the top row to this row. We would eliminate the x's there and just get a y plus 3z there. So that's how they get that one. And then to get the bottom equation, if we added 2x, if we added 2 times the first, if we subtracted 2 times the first row to this, and then we further subtracted, so what would we end up with? We would end up with, just by investigating it, adding 2 times that, or subtracting 2 times that would give me a positive 4 there, which means I'd have a negative y, which means I just need to add that equation and I'll end up with this form. And what's nice is you may say, well, why would you care about this form? Well, this form is in what's called row echelon form. And again, you may be wondering, why do you care about row echelon form? Well, as this next example shows, it's much easier to solve a system of equations when it's in row echelon form. So here, I want you to notice that since z is equal to 2, it follows that we can substitute back that into this equation, which gives us y plus 3z, 3 times 2 equals 5. In other words, we have y plus 6 equals 5, which means y subtracting 6 from both sides is negative 1. So we have z equal 2, y equal negative 1. And now that we know what both z and y are, we can solve for x in the top. X minus 2 times negative 1 plus 3 times 2 equals 9, which is x plus 2 equals plus 6, sorry. X plus 2 plus 6 equals 9. That's 8. Subtracting 8 gives x equal 1. And indeed, we believe we should have 1 comma negative 1 comma 2 as our solution. Let's check just to make sure. Plugging into the first equation, we get 1 minus 2 times negative 1 plus 3 times 2, which is exactly 1 minus 1 plus 2 plus 6, which is 9, so that's good. We also have in the second equation negative 1 plus 3 times 1 times 2, sorry, 3 times 2, which is negative 1 plus 6, which will be 5, which is good, so that equation works. And then finally, we see that indeed 2 is equal to 2 in the bottom, so we're good. And so what's nice about this is we can actually always solve a system of linear equations when it's in this form. So for example, go ahead and try out solving this in a similar way. On the count of 3, I will reveal the solution. 1, 2, 3. So as you can see here, I did this the same way, and I end up with that solution. So moving forward, this is going to be our strategy, and in the next, this is going to be our strategy trying to solve systems of 3 or more equations. For more practice, be sure to look at the textbook, pages at problems number 1, 2, and 7 through 16. In our next video, we're going to talk about how we can always get a system of more than 2 equations, or 2 or more equations, into that form, that sort of triangular row echelon form, by using Gaussian elimination.